we still need to go and see if that value of t is significant or not. So we still don't know the answer to our fundamental question, but we've got our t, and so now we need to go over to a table and look at this t value in the t distribution and figure out whether it's significant or not. Okay? What do we need to do in order to do that? Okay? Well, we need a little bit more information about this. So I'm going to go ahead and erase some of this, and then we're going to finish up looking up the t value and drawing a conclusion about our data. All right, so we're going to go to the t table, but in order to do that, we need some additional information, just like we did with the chi-square table. We need to know the significance level that we're interested in, and once again, just by convention, we're going to stick with the 0.05 level. So that means we're taking a 5% chance that we're wrong. We also need the degrees of freedom, just like we did with the chi-squared. And then finally, we need to know whether we're doing a one-tailed test or a two-tailed test. Those are the pieces of information we're going to need to go to the table and look up the critical value. Okay? So how do we get the degrees of freedom in this case? Well, the little formula, again, this is, I don't even need to do a formula alert on this one now. You guys are pros by this point, and this thing is so easy. It's just the number in the first group minus 1, and the number in the second group minus 1, and then you add those together. That's all there is. That's the degrees of freedom in a t-test table. Okay? I can calculate my degrees of freedom. In this case, it's very simple. It's 10 and 5, so I have 9. 10 minus 1 is 9, plus 4. And so my degrees of freedom equals 13. So I'm going to use that in the table. Now, when I set up my hypothesis in this case, I just said, I want to see if there's a difference between races. I didn't predict that one would be higher than the other. I just want to know if there's a difference. So when I state my hypothesis like that, and when I say that the difference between the races, the null hypothesis, that they're 0, that means that I'm doing a two-tailed test. I'm going to find if blacks are higher than whites or whites are higher than blacks. Either case, I'm going to support my hypothesis and reject the null hypothesis. Okay? So I have the significance level, the degrees of freedom, and whether it's a one- or two-tailed test. In this case, it's two-tailed. So let's go ahead and go to the table and look it up. All right? So you can see at the top, I have to pick whether I'm going to use a one-tailed or a two-tailed test, and I'm going to use 2 in this case. And then I go over to the significance level of 0.05 for that two-tailed test, and then I go down the t-table to the degrees of freedom, which are shown over here on the left side. And I go down to 13, and I go across, and that's the critical value of t, and that number is 2.16. Okay? That's the number to beat, as we've been calling it. So if my t is higher than this, I'm going to conclude that I have a significant finding. If it's lower than this, I'm going to conclude that I do not, and I have to accept my null hypothesis. So let's go back and see the t that we calculated. It was 0.57, okay? 0.57. That's less than my critical value of 2.16. And so I cannot reject the whole null hypothesis. I didn't beat my number, and so based on this sample, I would conclude that there is no difference between the races when it comes to IQ. That would be my conclusion. I fail to reject the null hypothesis. Not significant at the 0.05 level. And that's it for the t-test. That's how it works.